Thanks for joining us for Understanding Signal Isolators, Converters, and Interfaces. Before we dive into Part 6, let's recap what we covered in Part 5. We explored how isolators can boost drive capability in overburdened loops to restore signal integrity, and how they can pass or block HART communication depending on the application. We also looked at how multi-channel designs save panel space and reduce cost per point, and how microprocessor-based devices can apply custom linearization to handle complex nonlinear process relationships directly inside the instrument. In Part 6, we shift our focus to one of the most critical applications for signal isolators: safety instrumented systems. We'll explore key functional roles that safety isolators play in these safety-critical environments. First, we'll look at how area isolation protects your safety instrumented system from your basic process control system and other secondary systems. Then we'll cover how safety splitters allow process signals to be safely shared with non-SIS systems without compromising the safety loop. Finally, we'll look at how functional safety isolators can power field transmitters directly, simplifying wiring and reducing hardware in critical installations. Functional safety isolators and splitters are designed specifically for these critical SIS loops, providing isolation, signal conversion, and splitting where failures cannot be tolerated. These devices are available in 3 configurations to suit different application requirements: a 4-wire line or mains-powered isolator, a 2-wire loop-powered isolator, and a 4-wire mains-powered splitter that accepts a single process signal and delivers 2 completely isolated, identical outputs to 2 separate monitoring or control devices. When selecting a device for safety applications, a third-party approved isolator designed and built to IEC 61508 specifications is the best choice. Manufacturers can also provide FMEDA reports, failure mode effects, and diagnostic analysis, which supply the safety data needed to verify that risk reduction requirements are met. In a safety instrumented system, protecting the integrity of the safety loop is the top priority. Area isolation is the practice of using a functional safety isolator to create a protective barrier between the safety instrumented system and other systems such as the BPCS or a monitoring platform. Without this isolation, a wiring fault, ground loop, or power issue on the non-SIS side could potentially disrupt the safety loop, an unacceptable risk in critical process environments. By placing a certified functional safety isolator at the boundary, the SIS loop remains completely independent. Any failure or disconnection on the secondary system side does not affect the safety function, ensuring the loop continues to operate reliably when it matters most. In many installations, the same process signal that feeds your safety instrumented system also needs to reach a basic process control system, an asset management platform, or another monitoring device. A functional safety splitter makes this possible without compromising the integrity of the safety loop. By taking a single input signal and creating 2 completely isolated, identical outputs, the splitter ensures that each receiving system operates independently. A failure, disconnection, or power loss on the non-SIS side has no effect on the safety loop. This allows critical process data to be shared across systems while keeping the safety boundary firmly intact. Functional safety isolators can also serve as the power source for 2-wire field transmitters, adding another layer of utility in critical installations. When the isolator features transmitter excitation, it supplies loop power directly to the transmitter, eliminating the need for a separate power supply in the field. This simplifies wiring, reduces hardware requirements, and keeps the overall loop design clean and maintainable. At the same time, the isolator continues to deliver a fully isolated output signal to the safety logic solver, ensuring the safety function is preserved while the transmitter is powered and operating normally. In this video, we've covered how functional safety isolators and splitters protect your most critical process loops. We looked at how area isolation shields the safety instrumented system from failures in secondary systems, keeping the safety boundary intact regardless of what happens on the non-SIS side. We then covered the 3 varieties of functional safety isolators and how safety splitters allow the same process signal to be safely shared with non-SIS systems without compromising the safety loop. Finally, we explored how functional safety isolators can power two-wire field transmitters directly, simplifying wiring and reducing hardware while preserving the safety function. These capabilities make functional safety isolators an essential component of any well-designed safety architecture.